Your city has about 4 days of food. That sounds impossible at first. Most people picture grocery stores, pharmacies, and big-box retailers as the visible end of some enormous hidden stockpile. Rows of warehouses packed with months of backup supplies, waiting quietly behind the scenes. But that's not how the modern world works. In reality, most cities survive on motion. The food in your supermarket, the medicine in your hospital, the chlorine that keeps your drinking water safe, the fuel that powers trucks, the replacement parts that keep factories alive, all of it depends on a logistics system built for speed, not stillness. We call it just-in-time delivery, and it has transformed the global economy into a machine of breathtaking efficiency. But there's a catch. A machine built to run with perfect timing can also fail with brutal speed. Right now, somewhere beyond the coastline of your nearest major port, there may be dozens of ships waiting offshore. On those ships are thousands of steel containers. Inside them are pharmaceuticals, machine parts, canned food, electronics, clothing, fertilizers, medical equipment, and the countless invisible inputs that keep modern life stable. If the gates of a major port close for just 72 hours, the consequences do not stay at the waterfront. They begin to ripple outward. Store shelves are not empty on day one. Hospitals do not collapse in an afternoon, but deep inside the system, the pressure starts building immediately. The flow slows, then it tightens, then it begins to break. Hospitals may run short of specialized imported supplies. Water treatment systems may face delays in receiving purification chemicals. Manufacturers may discover that a single missing component, a valve, a circuit board, a sensor, a 50-cent chip, is enough to stop an entire assembly line worth millions of dollars per day. And once scarcity enters the system, prices follow. The cost of produce, medicine, construction materials, and consumer goods begins to rise, not because they vanished, but because every delay makes everything more expensive. That is the invisible chokehold, a disruption far away from daily life that quietly reaches into every home. Today, we're looking at the engineering marvel that feeds the world, and the terrifyingly small number of weak points that could bring it grinding to a halt. We live in the age of efficiency. In the modern supply chain, goods are designed to arrive exactly when they are needed. Factories don't want huge warehouses full of parts. Retailers don't want inventory sitting still. Storage costs money. Idle stock ties up capital. So businesses cut the excess, trim the buffers, and rely on precise timing. It works beautifully until something interrupts the rhythm. That efficiency comes at a cost. It removes slack from the system. Ports are not just loading docks. They are the arteries of civilization. Nearly 90% of global trade moves by sea. That means the overwhelming majority of the objects around you, directly or indirectly, spent time inside a shipping container. And once those containers reach shore, the real complexity begins. A port is not one machine. It is a chain of machines, people, software, vehicles, schedules, and infrastructure all synchronized to the minute. A container ship arrives on a narrow timetable. Giant cranes lift containers off the vessel. Trucks move them across terminals. Rail systems carry them inland. Warehouses receive, sort, and redirect them. Distribution centers push them toward regional stores and facilities. It is less like a harbor and more like a 10,000-mile relay race. If the crane operator doesn't show up, the ship waits. If the ship waits, trucks sit idle. If trucks sit idle, rail departures are missed. If rail departures are missed, inland warehouses don't receive inventory. If that inventory includes one crucial component for a factory in Ohio, Michigan, or Texas, that factory may shut down, despite every other part being ready to go. That is the real lesson of ports. They do not merely move cargo. They connect systems. Shut one down, and you stop the choreography that keeps entire regions alive. And while ports are engineered for resilience, they are not invulnerable. Many major ports are hardened against storms, backed by redundant power systems, and protected by layers of physical and digital security. But resilience is not immunity. One vulnerability is labor. Dock workers are highly skilled professionals, performing dangerous, tightly coordinated work in a high-risk environment. When labor disputes occur or staffing suddenly collapses, the choreography breaks down. In 2002, a labor dispute shut down 29 West Coast ports for 10 days, with economic losses estimated at roughly $1 billion per day. Another vulnerability is software. Modern ports are digital ecosystems. Cargo manifests, customs clearance, crane scheduling, gate access, trucking appointments, rail coordination, and warehouse routing are all managed through interconnected systems. Those digital systems are vulnerable. In 2017, shipping giant Maersk was hit by a massive cyber attack. Screens went dark, systems froze, gates locked. In one of the most advanced logistics networks on Earth, people were suddenly reduced to paper, pens, and manual guesswork. The attack disrupted operations across ports and terminals worldwide and cost the company hundreds of millions of dollars. Then there is nature. In 2012, Hurricane Sandy shut down major East Coast ports for nearly a week. Flooded terminals, damaged equipment, and power failures crippled one of the busiest trade corridors in the United States. And the long-term trend is not reassuring. As sea levels rise and extreme weather increases, more ports face increasing flood risk. Sometimes the threat is not weather or code. Sometimes it is pure physics. A single bridge, a single channel, a single navigational bottleneck can determine whether a port functions at all. When the MV Dali struck the Francis Scott Key Bridge in Baltimore in 2024, one of the East Coast's key ports became inaccessible in seconds. That moment was a reminder that ports do not stand alone. They depend on surrounding infrastructure: bridges, shipping channels, road access, rail connections, fuel supply, and power grids. Damage one supporting structure, and the port can become useless overnight. Ports are also strategic targets. In war, they matter because they are gateways for both economic power and military logistics. In geopolitical conflict, you do not always need missiles to cause damage. Cyber warfare, sabotage, blockades, and targeted disruptions can destabilize a country by choking supply chains silently. The methods may differ. The result is the same: the flow of goods stops. And when that happens, the system does not collapse all at once. It tightens first. Imagine a rubber band stretching to its limit. Under normal conditions, it works beautifully, but it has no slack. During the first days of a shutdown, ships begin stacking up offshore in a floating traffic jam. Within a week, manufacturers start throttling production. Automotive plants pause shifts, construction projects stall. Warehouses run unevenly, some overwhelmed, others starved. If the shutdown lasts longer, the disruption becomes visible to everyone. Retail inventories shrink. Certain medications become harder to source. Replacement parts get delayed. The price of everything goes up. During the 2021 shipping congestion crisis, container rates increased roughly fivefold. Those costs did not disappear. They moved downstream into grocery bills, furniture prices, appliances, and everyday consumer goods. That is how the invisible chokehold reaches your kitchen table. Before we look at what happens when the gates finally reopen, consider subscribing to Engineering Your World. We break down the invisible systems that keep your city alive, because these systems only seem to matter to people when they fail. So what happens when the gates finally reopen? Recovery is a giant knot that takes weeks or months to untangle. Ships must be rescheduled. Containers must be rerouted. Rail slots must be reassigned. Truck drivers must be repositioned. Warehouses must absorb unpredictable surges. Ports may expand to 24-hour operations to clear the pileup. Governments may accelerate customs processing or invoke emergency coordination powers. Some cargo may be diverted to other ports. High-value goods may be sent by air at enormous cost. But even under ideal conditions, the delay echoes long after the cranes start moving again. That is the paradox of modern logistics. Stopping is fast. Recovery is slow. Are port shutdowns becoming more likely? The uncomfortable answer is yes. Climate risk is rising. Cyber systems are growing more complex and more exposed. Global politics are becoming more unstable. Infrastructure in many places is aging. And at the same time, the entire world is becoming more interconnected, which means disruptions spread farther and faster than ever before. We have spent decades engineering a world optimized for efficiency. Now we are being forced to confront a harder question. Can we engineer it for resilience? Because efficiency alone does not keep a city alive in a crisis. Stability does. Redundancy does. Preparedness does. Civilization is not just built on roads, bridges, buildings, and power lines. It is built on flow. The invisible movement of containers, chemicals, fuel, medicine, and food. The unseen choreography that begins at sea and ends in your refrigerator, your hospital, your factory, and your tap water. And when that flow stops, even briefly, the illusion of abundance disappears. That is the invisible chokehold. Not a dramatic explosion, not a headline-grabbing collapse, just the quiet realization that the modern world is held together by movement. And that movement depends on far fewer points of failure than most of us ever imagine.